This lesson, we learn how to find a voltage drop on a single capacitor, and this capacitor connect in series with other capacitors. This is the formula to find the voltage drop. Voltage drop on a single capacitor is called Vx, where x is the index of the capacitor we refer to. For example, if x equal to 1, it refers to the capacitor C1, and the voltage drops on C1 is V1. If x equals to 3, we refer to capacitor 3, C3. The voltage drops on capacitor 3 is V3. Vx can be calculated by the total capacitance of the system, Ct, divided by its capacitance, Cx, times the total voltage applied to the capacitor system, called Vs. We are not going to prove this formula. We just learn how to use it. In my opinion, the best way to help us remember this formula is to analyze it. So first, let's look at the Ct over Cx. Since Ct is the total capacitance of a n capacitor series circuit, so Ct is smaller than Cx. So the ratio of Ct to Cx is always smaller than 1, or is always less than 100%. This number multiplies the total voltage dissipated on the entire system, Vs. It is a small portion of the total voltage dissipated on the system. And this is the voltage drop on the capacitor X. Let's look at an example here. In this example, we need to find the voltage across C1 and C2. Step 1. Find the total capacitance of the system. The total capacitance Ct equals to the equivalent capacitance Ceq, and equals to C1 times C2 divided by C1 plus C2. And let's plug in numbers. 200 times 300 divided by 200 plus 300. Since the unit of this capacitor are all in microfarad, I just temporarily omit it in calculation. 60,000 divided by 500. It equals to 120 microfarad. Let's say V1 is the voltage drop on the capacitor 1, C1. According to the formula, V1 equal to Ct over C1 times Vs. So V1 equal to 120 microfarad divided by 200 microfarad times 12 volt. V1 equal to 7.2 volt. For V2 equal to C total divided by C2 times Vx equal to 120 microfarad divided by 300 microfarad times 12 volt. V2 equal to 4.8 volt. Note here, if we add V1 to V2, we got 12 volt, which equals to the total voltage drop on this capacitor system. So we have a different method to find V2. For V2, we can use the total voltage Vs, subtract the voltage that drops on the first capacitor V1. That equals to 12 volt subtract 7.2 volt, and that gives us a 4.8 volt.